Okay, here we are on day 2 of this mod, and we are looking this time at a new force. So we know force equals ma, and we have come upon the fact that a weight is mg. So we have weight equals mg. When we talk about weight, it's understood that weight is downward. So I put in the negative sign. Yesterday I didn't, but when I say I weigh 151 pounds, then I am saying that my weight is a downward force. So the word weight infers that. But I'm actually going to show you this man standing on the surface of flooring, and his weight, his force, the weight of his force, the force of his weight is downward at negative mg. Remember, weight equals mg, so this is a picture of his force, and its amount is negative mg, his mass times the acceleration due to gravity. So, my question for you, if there is all this force provided by his weight, why does he not crash through the floor to the Earth's center? Because that's where gravity is drawing every object. So why does he not crash on through the floor and keep on crashing through everything? Why isn't this force pulling him through this surface? Well, there is another force involved, and that's our force. Our attention is going to be on that force today. There is a force provided by what? That is pushing up on the man. It is provided by the floor. So this surface, notice it's perpendicular to the force of the weight mg, negative mg is downward. There's a force provided by this surface that is preventing the man from going crashing through the floor. And that force is mg upward. So the man is not floating up, he's not crashing through, so these forces must be equal, keeping him stationary, standing here in his spot. So this force upward is provided by the surface he's standing on, and it has got a name. It's going to counter his weight exactly. And we know the sum of the forces equals ma. The man is not going up or down, so the force, sum of the forces, he's not accelerating, he's still, so it must be 0 on this side. So the two forces, the force downward from the weight and the force upward from the floor, must be equal to get 0 because there's no acceleration. So there's no net force. So it is a perpendicular force. Notice the floor is providing the force, but the force is upward. So we have this perpendicular arrangement. So I indicated that with a symbol for perpendicular right here. It is a perpendicular force provided by the surface that supports the object, and we call it force normal. Normal, the word normal is an old school word that means perpendicular. So that's why we call it force normal. Force perpendicular would say the same thing. Sometimes we call it the normal force. So either order is acceptable. So our topic for today then is force normal. All right, and that answers our question, what keeps the man from crashing through the floor because of his weight downward? It is countered exactly in the same amount upward by force normal. So, the normal force is always perpendicular to the surface applying it. So I made mention of that, so I put it in words as well. So, let's do a problem here. We have a 75 kilogram man, And we want to find the normal force that the floor exerts on the man. So we know that this mass, 75 kilograms, is creating a force downward, negative mg, but we want to know what is the countering force, the mg upward. Well, all we're going to do, our strategy, is just find his weight downward, and we know force normal is exactly the same upward. So we're going to grab force normal, force perpendicular equals mg. Force perpendicular is mass times acceleration, and that will get you the force. And notice if I asked you to find his weight, it would have given you the same calculation. So 75 times 9.8 is 740. We're working in metric, so we have newtons. 740 newtons upward is the normal force. So when I don't put a sign here, it's indicated or understood that it's positive. So it's an upward force of 740 newtons. So I only want to mention, other than that, is if the floor is rotten, if we're standing on a rotten floor, so here we have a guy standing on a rotten floor, so not sure how to draw a rotten floor, but there's my best attempt. It turns out that his weight is downward, and force normal might not be strong enough to offset his weight downward, and he will crash through the floor. So if anyone has any stories of crashing through surfaces, this is the time to share them. All right, so the rest of our day we'll practice calculating force normal. Mr. DeBloom will assign you one of those that you'll find in your textbook, but they only had one, I believe. So I have selected 10 more to put up on the board, and you can find force normal for each of those problems and then check them. Mr. DeBloom will have the answers as well. So that's all for our day 2, so carry on.